3 and 2 and 1. And let's start. Welcome to today's webinar with the title New UL Listing for RIGID.flex, Maximum Performance and Highest Safety. I am Andreas Schilp, your host and speaker of today's Würth Elektronik Circuit Board Technology webinar, and I would like to welcome you. The speakers in today's webinar are two qualified specialists from Würth Elektronik, Würth Elektronik from our technical project management, and me. Together we have over 50 years of experience with printed circuit boards and customer projects. You can find all previous webinars on our Würth Elektronik YouTube channel and on our website, both for the relevant technologies and in the support section under Knowledge and Video Center. The easiest way is to use the short link on this slide. Then you will land correctly in the Video Center and the filter is already set to PCB. As a warm-up, I'm interested today in whether you already know our vision, perhaps just a part of it or a keyword maybe. So now you can enter this in the question field, or you can also enter where you are watching from and how maybe the weather is. Here in Künzelsau in Germany, it's quite pretty, sunny, perfect, a little bit cold, but will be better in a few hours already. Okay. So please use the question field to tell us whether you know maybe our vision in total or maybe a part of it, or how the weather is where you are located. So from France it's very sunny. Congratulations. From Netherlands it's also sunny. Okay. UK. How about UK? Nice weather as well in the Netherlands already, yes. Peter from Denmark, sunny but cold. Yeah, okay. So it's all the same over Europe, it seems. So welcome to the webinar. And last but not least, I want to solve the mystery what our vision is. Our vision is we understand our customers' needs and provide solutions for the printed circuit boards of tomorrow. So that's it. That's our vision. So this is the agenda for today, and I myself will cover the point 1, Introduction, Underwriters Lab, scope of a UL listing, parameters and correct specification of a UL compliant PCB. Then my colleague Würth Elektronik will take over and talk about UL special features for RIGID.flex, the procedure of the listing and the new listing of the WE63 in detail, and our support for you, for our customers. Okay, so let's start with the introduction into UL. So the history tells us that it was 1894 when William Henry Merrill had the task from the US government to regard a building with regard to electrical risks. There was the World's Fair and a palace of electricity, and he cared for the product safety long time ago. Merrill developed standards and tests, designed the necessary equipment and identified potential sources of danger. There was a close cooperation with insurance companies, and that's why it's called Underwriters Laboratories. Okay, so in that time there was no separation of powers as we are used to in Europe, especially Germany. So, for example, in Germany, we have different organizations for the standardization on the one side and for the testing on the other side. So, example, if we are not okay with a TÜV, we can choose another company, maybe DEKRA or something else. But regarding PCBs and the final certification, that's not so easy. Of course, there are other certifiers for components, as the PCB is a component for the end usage. But finally, UL is always responsible for the final acceptance. So there's no other way. And this makes UL a very strong brand. And my experience is that it's increasingly profit orientated, so everything costs a lot of money. We will talk about that later on. So what are the drivers for the UL component recognition? So on the one hand, it's fire, of course. The PCB could act as a fuel source and could be ignited, maybe. So that's a general risk, of course. And the other thing is electric shock caused on breakdown of isolation and maybe breakdown in mechanical strength. So regarding the end product certification, there are a lot of standards requiring UL recognized PCBs to be used. And this is always, the requirements are always application dependent, and they should be verified in detail before defining a PCB UL type. Okay, so let's have a deeper look into the fire thing. So fire is tested according to UL standard 94. And there's, of course, a rating. We can see the criteria on the right side. So the ratings are called V0, V1 and V2, and the lowest rating is V2 and the best rating is V0, but at the same time the most complicated. How does that works with the testing? Let's have a closer look at the test itself. This is a test situation. Let's have an orientation in the picture. Here we have a clock, stopwatch. The yellow stripe is the test strip, out of PCB material. It's within a clamp here on the top side, and here we can see a blue flame. This is a burner with a blue flame, and this will, after the start, this will move to get into contact with the test strip. And the clock will start running, and then let's have a look what's happening. So while contact with the flame, now the burning starts a little bit more and more. Then after 10 seconds, the flame disappears, now away. So this is a short afterglow. Next flame, again 10 seconds to the test strip. After 10 seconds, removing the flame. Now, okay, and there's another burning and afterglow. So that's the test, two times the flame, 2 runs, and so the test result is very good. So there's no long burning, so the result is V0. Let's come back to this criteria table. So we had an afterflame for the first time and the second time less than 10 seconds, and the total afterflame less than 50 seconds, and afterflame plus afterglow less than 30 seconds, no after flame or afterglow, up to the holding clamp. It's never allowed, and a cotton indignator was not ignited at all. So this is a clear V0, the best we can get. What is the purpose and the benefit of a UL listing? So an obvious benefit is that we get a characterization of both material and complete PCB bareboard and the properties of them. It acts as a guide for designers to select the material and the PCB that suits your requirements and has the related properties for that. Then if we have a UL listing, the PCB is a registered component and assessed for use as a component in end products with UL requirements. So this UL recognition gives the user confidence that the PCB and the process and the material and everything which is watched meets certain requirements when it was assessed. And there's a test program with rules, with tests, and this helps to improve safety. And there's a follow-up service by UL inspectors in the field, and so that means both the materials, the processes are checked whether they are fitting to the UL listing, whether we are using the correct material, whether we are using the correct processes with the correct parameters within the process. So that's an ongoing process on a quarterly basis. We see a follow-up service by an UL inspector, and if the UL inspector finds the PCB does not have the appropriate recognition, they will raise a variation notice, and this is could be quite severe, up to a stop shipment or forcing to remove the UL mark from the product. So I remember situation with a customer. Customer had the final products ready to ship, and the UL inspector noticed that the UL mark was not the correct one, fitting to the product description within the UL papers. So in special, it was a requirement for MOT, maximum operating temperature, which was not covered by the used UL type. So that could be solved by replacing the UL type. There was another UL type which could be applied for the PCB without any other choice. So that was a quick and easy solution, but it could also happen that you have to scrap the products and cannot sell them anymore. So that's quite a severe situation maybe. So there's a difference in the locations and the UL listings. So we have a category control number which is called ZPMV, and there's another number, A2 or A8. The 2 stands for USA and the rest of the world, and the 8 stands for Canada. So there's an additional listing for Canada, and this CCN ZPMV8 could be reached by paperwork, but we have to order this with UL, and they compare the materials listed and whether this could be applied also for Canada. So we at Würth Elektronik CPT, we also have Canadian approval with identical parameters for all materials and listed PCB types. So this enables labeling with this CURUS label you can see here on the bottom. Let's have a look at the registration levels. So regarding flammability and all the testing beyond, there are two general categories. There's the more easy level of flammability only registration, and there is the full package, let's say, the full recognition. And it's very important to understand the end product requirements before specifying the recognition level which is needed. Let's have a look at the comparison on the bottom. So if we are talking about flammability only recognition, that's easy and small compared to the full recognition. So for flammability only recognition, of course, the flame rating is done. We have to perform the flammability test we watched in the video, and there's the need of the definition of solder limits. There is no MOT available, no direct support requirements, and no comparative tracking index. We come to these parameters later. If we have the recognition level, full recognition, we have all the parameters stated and tested and listed. So MOT means maximum operating temperature. That's not quite the same when we talk about the actual mission profile of the application. So it's more or less an interpretation by UL, meaning the maximum continuous operating temperature to which the PCB can be exposed under normal operating conditions. And this MOT, for example, 120 degrees C or 130 or 105 degrees C, these are typical values for MOT. This value is used to determine the conditioning temperatures in the following test methods: adhesion, delamination, delamination of different dielectric materials. So in the middle we can see DSR, that means direct support requirements, and these requirements are depending on the material and its thickness. Combination of different properties is assessed. I will not go into more details as this is really complex stuff. But there's no specific test, so it depends on the base materials and the values in the specification sheets and the listings at UL, of course. So normally all the base materials, the inks, and all the other coating materials are pre-listed by the producer at UL, so we can refer to these pre-listings. CTI means comparative tracking index, and the picture shows us a measuring arrangement for determining the tracking index. And we can see a material on the desk here. This is the bulk material. It's a massive, thick bulk material. We have two electrodes here and here, and then we have a salt solution which drops from here in between the two electrodes, and it's watched for 50 drops, and finally the value shows which voltage could be applied without any breakdown. So this is the CTE, comparative tracking index, so it's related to the material. And due to the flexible material, when we are talking about rigid flex, we always use polyimide foils and without any adhesive, so it's pure polyimide, and this is classified as CTI4, so 100 up to 175 volt, it's not possible to get an CTI higher for rigid flex. So actually we can discuss about that, as normally no unprotected conductive structures on polyimide are outside, and so yeah, but it does not help. UL is working like this. So CDI 4 is the maximum we can have for rigid flex technology. So the elements which are approved for a registered PCB are 4 elements. It's material, base material, resist, plug-in paste, ink for legend print. It's construction regarding the stack up, the location of the flexes, thicknesses, copper thicknesses, bending type, wire construction, and last but not least, the assembly type, one or both side assembly. Third thing is parameter. Of course, we have seen the flame rating, MOT, we have discussed already. There are design limits. So Werner will talk about that later on. And soldering parameters. And the fourth column here is production process. So we have to specify in detail how the PCB is produced, especially with all the processes higher than 100 degrees C. We have to specify all metallization processes, all solder surfaces, all coatings, and finally all external processes which are not made in-house. There is a new thing regarding the soldering processes. So since end of 2020, there is a new definition of soldering processes, and it's based on the IPC TM650, chapter 2627, thermostress convection reflow assembly simulation. So that's more practical. It's nearer to what you are doing with our PCBs. So in the past there was a summary of all thermal loads with a time and a peak temperature, but that was a bit theoretically. So today the new specification is more nearer to the practice you are doing. So the previous solder limits are replaced by assembly solder process IPC, specifying a solder profile with peak temperature and the number of cycles. So a standard is 6 cycles of the IPC T260 profile, soldering reflow profile. The old listings remain unchanged unless they are not changed due to other changes in specifications or materials, and all new listings will have this new specification. And finally, UL inspectors will check the new parameters when UL labeled PCBs are assembled. So that's quite important to match to the parameters which are specified in this UL listing. So how to get a correct UL specification? There are some UL specifications which could be applied. So, for example, if you are dealing with industrial control panels, there is the UL 508A, and some others you can find here. And in this UL specifications, you find the UL notes in the certification documentation, maybe called as section general or as critical components in the description. And here we have 3 examples. The first example shows that there is the requirement of an MOT 105 degrees C or higher. So that's one example you can find in all these UL specifications. In the middle we have a quite different one. So here we have the requirement again, MOT 105 degrees E or higher. But there are also requirements which do not need MOT at all. So that's also a possibility. What's interesting here is that the flammability rating requiring is V2 minimum. So it could be also V1 or V0, but it's not needed that we have V0. V1 or V2 is absolutely okay for this application. And there's another requirement suitable for UL 796 DSR. So direct support requirement has to be meted. And the third example shows that there is a rating required V0 definitely, so V1 would not be okay. Okay. So how to specify correctly a UL compliant PCB? So first of all, try to get as much information as possible in the documents I've shown. Care for the UL CCN. So CCN means category control number. That's a code used by UL to differentiate product categories. For example, if you are dealing with programmable controllers, the CCN is NRAQ. If you are dealing with sensors, in that case proximity switches, the CCN is NRKH. Okay, so that's just a few examples to show how this works. So find the correct UL product category, read the guidelines. They provide information about the requirements, maybe about flammability. Is flammability only sufficient? If yes, is V2 or V1 sufficient? That's cheaper finally. Is MOT necessary, maximum operating temperature? And it's really important not to make copy and paste. It's often done like that. So you had no time for a in-depth search about the requirements for the new project. So let's take the UL specification from the last project. That could work, but it could also be that you get an over-specification, which makes things not really better, but more expensive and more complicated. Werner will talk about that in a few minutes. So no over-specification, no copy and paste, and as always, talk to us. We would like to assist you. Finally, last slide for my part, which is still introduction into UL. What must and what can be included in the labeling? So again, we can see the labeling here. So we say that it is a must that we can see who is the producer of the PCB. So this is WE, Würth Elektronik. That's our manufacturer logo. So it would also be nice to have a date code that's here, 0725. That means week 7 this year. So it's important to have this on the board. And it would also be nice to have a lot number, which production lot is this PCB. That's not shown here, unfortunately. So UL marking, regarding the UL marking mandatory is manufacturer identification. There is the E number, but in this case we have the WE, Würth Elektronik here, followed by the UL type. In this case it is 63A. This is that. So, and that's enough regarding the UL requirements. Optional, we can have factory marking, which is within this circle here. And we can have the UL mark, which is UR for registered component. And we can have the flammability classification. This is here, 94 V0 in this case, so the best we can have. So that's the last thing regarding the correct labeling. So it could be less, definitely. It's a must to have the WE65A, but that could be enough. Okay, so that's it regarding the introduction. To be honest, it was a long introduction, but it's a really complex topic, and I think it could help to answer some questions in the pre-field. And now I hand over to Werner Oechslein, and he will give even more details and especially covering all the RIGID.flex topics. Okay, Werner, it's up to you.
Thank you, Andreas, and thanks for your detailed UL basics. Now we speak about flex rigid technology. First, only a slide to show you what is a flex rigid PCB in general. I only would like to show what's the difference in between a standard multilayer and a rigid flex PCB. As you can see, we have a lot of more materials and materials combinations behind. That means we have an additional polyamide, we have a cover lay, and these materials are in direct contact to other materials. And all materials which have in direct contact to another material must be tested at UL. But with this we will see later in the samples which we need for such a for an UL release. In this webinar we only speak about rigid flex boards, the UL sign of rigid flex boards, and not of pure flex boards. Some more basics. The slides we already have seen in Andreas' presentation regarding material construction, parameters, production process. So what is special if we are using a flex rigid PCB? First of all, we have the materials itself. What we are using for each flex rigid PCB is a polyamide material. You can see this on the right side. It's a brown material with a copper on one or two sides of the polyamide material. There are different core thicknesses possible. It begins from 25 to 100, it's standard. 125, 150 is possible, but that's already special. And we also have different copper thicknesses. It begins also with 18 micron, and the maximum what we are producing is 17 micron. This copper also with different qualities for, I would say, flex to install application or for dynamical bending. Why I'm showing this slide? It means only we have different material thicknesses. So if we want a UL release, we have to test mostly the thinnest material and always the thickest material for a UL release of such a polyamide material. What comes on top if we have a flex rigid? It's the cover lay foil itself. So the cover lay, it's a polyamide foil with different thicknesses, you can see here, and also with different adhesive thicknesses depending on the copper structure we have to embed. So the cover lay is the protection of the flex area to cover the lines, the structures on it. One more is a bond ply. Bond ply, it's from material the same as the cover lay, but we have at the bond ply, we have the polyamide in the middle, and we have on top and on bottom an adhesive. That means a bond ply is used if we have more than two copper layers in the flexible area, maybe 4, 6, 8 layers in the flexible area, and we have to press or we have to glue the different flex layers together. Then a bond ply is used. So a lot of different thicknesses in acrylic or in the adhesive and the polyamide. And as a standard rigid PCBs, we have also a combination with the rigid materials. The one is the prepreg. Oh, as I can see, it's still in German. Sorry for this. It's the glue in between. We have the low flow prepreg. A low flow prepreg is used special for RIGID.flex PCBs. That means the resin is not flowing that much as with a standard prepreg. And we have the cores itself, like at a standard multilayer PCB. That means different core thicknesses of FO4 material, which we are using in this case. And these are on top and bottom with a special 12, 18, 35, 70 micron copper foil. So now we have a combination of polyamide material with the different foils as coverlay bond ply, and we have the rigid laminates. So our standards, you can also see them on our homepage. These are our standard stacks for flex rigid. It's on the left upper side with one layer of flex outside, so it means one copper layer of flex outside, and I would say X numbers of rigid layers in the rigid part. We have then here the 2F, two copper layers outside in the flexible area. Then we have the stack with two flex layers in the middle and 4, 6, 8 layers flex in the middle itself. So as you can see, we have here a lot of different material combinations or materials which come to another material, and all these variants must be tested. So for example, polyamide to the solder mask, polyamide to the coverlay, polyamide to the rigid material, and it's everywhere. Yeah, it's a lot of different combinations which are possible. All our standard stacks in this case are a one-time lamination. That means it's pressed only one time. In this case, also additional micro vias are inside. If we have now a PCB with more than one micro via layer or a bird via layer, an additional pressing comes on top. And as Andreas already mentioned, every process, especially the processes which are more than 100 degrees, must also be added to the UL process parameters. So, for example, a RIGID.flex PCB, here now the flex in the middle, we have here 3 times micro vias staggered in this case and additional bird via. So for example, 4 separate pressings, so the first pressing, second, third, fourth pressing. So then we need in our UL report 4 times pressing inside. Yeah. So a lot of processes, additional processes which come on top. So now we have seen we have different materials, we have different stacks, and we have different pressing things. So what have we done now? We cannot test all the different parameters, all the different stacks, because this no one will pay. We have now focused, I would say, on our standards, our standard material and our standard stacks. That means our new UL release defines in general 3 stacks. It's still 1 flex layer outside, 2 flex layers in the middle, and 2 flex layers outside and 2 flex layers in the middle. What's also special, you can see we only have make this new UL release with a coverlay foil inside and also outside the flex part if it's on the outer layer, and also inside only with cover foil. So no flexible solder mask. The reason I will come back later. Okay, then we also have for both, we have filling material inside with the solder mask inside, with also a cover lay on the rigid material outside with the solder resist itself. And as you can see, we don't only have only one polyamide material or one FO4, so all the different manufacturers of the materials must also be tested. So what are we defining at the beginning? So in this project we have done, at the beginning we have done all our materials, all our stacks together. We have defined then up to, I would say, 4 or 5 times pressing, and we have done all these documents to UL. And they came back with the first sample requirement list. That means which samples we have to produce, and with the first costs. But the first costs were that high. I would say it's more than 150,000 euro to get such an UL release. Only for the testing at UL. So with this costs, no samples are produced. So that means in the next step, we are beginning to focus on our standards. That means we are making materials out. We are saying, okay, we don't need 5 pressing cycles for our, I would say, most products. So 3 pressing cycles are enough, for example. And then we come down with this sample requirement list and also with this testing. So this, for example, is such a sample requirement list of UL. So we can look a little bit more detailed. There you can see all the different samples which UL requests. That means the rigid samples with solder mask, the rigid samples with cover lay, then when the flex is in the middle, when the flex is outside, for the pure flex with flex mask, with the different cover lays, the different adhesives. That is our, I will say this were more than 200 different samples which we should produce. So what have we done finally? So we have focused on our most common standard stacks, common materials. And at the end, we have had 74 different stacks, which we produced for UL, and layout samples. And from each type, we have produced 20 samples, roughly. So what samples are this? So Andreas reported already of these V samples. So these are the vertical burning samples. So they want now a sample of each combination which is possible. That means we have the pure polyimide material. We have the pure polyimide material with cover lay thickness A, B, C, D, E, F. Then they want it with the flexible solder mask, with the rigid. So a lot of combinations. The same is with the delamination, the lamination samples. You could see here this is the UL layout which you need for all these samples. That means there's the minimum line width already inside, and the minimum line width also at the edge contact, which must be defined. It means this line is maximum 0.4 millimeters away from the border of the PCB itself. And at the end, UL is doing the tests with the copper adhesion on the base material and says whether the sample is at the end okay or not okay. Also with the banding samples for ambient band, cold band, these are the samples. Also with the different cover lays, different flex masks and so on. RF samples at the end are also samples for dynamic bending load. You could see here there's some contact already where they measure the ohms, whether maybe a crack or something happens in the lines. Yeah. So all the samples must be delivered. So with these 74 samples at the end, only for testing and all the documentation at UL, it still costs such an UL release roughly 70,000 euros. Yeah. And on top, from the PCB supplier comes the sample production. So a lot of costs for such an release. So what we have now in our UL file. So this is the UL number of Würth Elektronik. So if you do it in your browser, you can find also these slides here under. Yeah. Here are now the 66, 65, and 63 are our flex rigid listings. So 66, I think it's of 2012, 2014. Still, it was in full recognition, as you can see. MOT, DSR, and everything is inside. Then we have done beginning of 2018, I think, the 65. It's only a flammability only release, as you can see here. Only the flame class is inside, VO and V1, depending on the stack or the material which we use. And now new comes on top, this 36A and 36B. Which is also a full recognition with a little bit other characteristics. Minimum line width is other, the flammability is other. We have now an MOT of 130 degree, and this already Andreas reported. This comes new in 2020. Before it were the solder limits, 288 degree 20 seconds, And now new is that the assembly process is defined with 6 times 260 degree. Good. More detailed, our new file means we can go down to a material thickness, in this case of 1.5 millimeter for D-stacks and 0.7 millimeters for a 2F inside. So it's more complicated for the production than to come down to this thickness. One more thing, it's the min line width, which is new. We have now 50 micron line width with the minimum. We can go up to 70 micron copper. We have the 6 times reflow process inside. We have the maximum operation temperature of 130 degrees. We have the flammability of VO, DSR, direct support rating we have. And as already mentioned, we have the CTE4 because of the polyamide material inside. So this is our new UL listing, and I think this fits nearly for all applications which are on the market. Yeah. So what is our main thing always? That we want the contact already in the concept phase. That means you have to check the guidelines according for your application and check the minimum requirement for the PCB. If you have only, I think, as I said before, we have for all our standard specs a flammability only recognition with V1. But if you want more than this, contact us. Then we can discuss about the material, the stack, also the production processes, if it fits at the end to your application. So really, really important in this case. One thing is, for example, as I said, we don't have in our full recognition sign, we have not all materials inside. So we also have, for example, if the flexible part is on the outer layer, we have a flexible solder mask. This we only have currently in our old UL listing with a flammability V1 currently. And it's a cheaper solution in comparison to cover lay. If you need a MOT or DSR, we need to go for a full recognition sign. That means the stack itself gets a little bit more complex and at the end more expensive. Come already to the summary. So check your requirements carefully and avoid any overspecification. Use our standards and special features. Contact us for this. We offer different UL listings, also for our RIGID.flex, also for our multi-layer HDI PCBs, where for each, I would say, technology in UL file. And we are very, very happy if you could support you already at the beginning of the project.